All right, so today we're going to talk about arcs and chords. So, do you remember what is an arc and what is a chord? Hello, Grayson? So,
Oh, sorry. It's the curved, like part of the circumference.
very good. So, arc actually is part of the circle. Good.
Okay.
When we talk about circle, actually we talk about uh basically all the points had the same distance to the center. That means when we talk about circle, we actually means that this kind of whatever we call that, this kind of curve we call that. So arc is just part of that. How about chord?
It's the line connecting those two dots.
Well, it's actually a line that intersect the circle at 2 points. Good. It's a line segment, basically 2 points on the circle. Now we're going to looking at theorem. Uh, the first theorem of this lesson. So, oh, Mia is here. Hi, Mia. How are you doing? Yeah, can you hear me, Mia? Hello, Mia. Can you hear me? Oh, there's two. Hello, Mia.
Hi.
Okay, all right. That's good. Okay, so we just got started and we're talking about arcs and the chord. But arc is part of the circle. So basically the circle we in by definition in geometry and in math, we're just talking about all when you connect all the points have the same distance to the center, and all the points, of course, we got infinite number of points, but all that makes a circle. Um, so which is kind of different from what we normally says. Like when we say the area circle, we're talking about normally we think about circle is the whole thing here. But that's not the case in geometry. Geometry talking about circle is basically inaccurate. Uh, exact wording will be all points had the same distance to a center. So basically, that's this kind of curved line. That's a circle. Um, and when we talk about area of a circle, we actually talk about area of the region that is uh, surrounded by the circle. Okay, so that's kind of different from what we normally say in everyday life. Okay, and then a chord is basically a line segment connecting 2 points on the circle. So that's a chord. We also learned about tangent. Tangent is actually a line go through, touch the circle at one point. That's a tangent. So a tangent actually is a line. A chord, we call that a line segment. Now, a line segment has length. A line doesn't because a line is infinite long. And we also learn if a line goes across something like this, and that's called secant. Secant is also a line. And but they intersect the points, a circle at 2 points. Now, between these points, this is a line segment. We call this chord. So that's the definition we have here. Okay, now let's look at the first theorem. First theorem says that in the same circle, I can clear this. In the same circle, all incongruent circles. So that means they have the same radius. And there's a relationship between the arc and the chord. So basically is that if uh, the first one said congruent arcs has congruent chord. So if this arc, I'm going to use different color. If this arc here is congruent to, say, this arc, then this line segment, which is a chord, and this also chord, and these two chords are also congruent, which kind of makes sense if you look at the circle. Yep, so this is the arc. If these two arcs are congruent, then the corresponding chords are congruent. And it is also true the other way around, is that if we have two congruent chord, like this chord, and maybe a chord that go like that, and then the corresponding arc are also congruent. So that's basically what it is. Okay, so let's see how we actually can prove it. So we got that. We got a circle. We have an arc. They are congruent. We're trying to prove that their uh, chord are also congruent. Now, when we prove things, as we have seen in the past, a lot of times we use uh, triangle congruency to prove other congruencies. So let's say we got RS is here, and we have TU. It doesn't matter where they are. Let's say this is a TU. We know that they are congruent. That means they have the same length on the circle. Okay, now what we are trying to prove is the corresponding arc are congruent. So what we're going to do is that we're going to get to the connect that and connect that. Now we got two triangles. So we just need to prove that the two triangles are congruent. And based on CPCTC, then the con oh, CPCTC, not P, CPCTC. So congruent parts of congruent triangles are congruent. Okay, so if we can prove the two triangles are congruent, we can say ROS triangle is congruent to TOU. Then we, based on CPCTC, then the arc RS definitely will be congruent to TU. So to prove that, we know that we can either use SSS or SAS or ASA or AA angle side. We got four of those. So on this one, we know the arc is the same congruent. So this angle has to congruent to that angle. And we know this side is congruent to this side because they are all radius. So we got a side angle side. So we use side angle side. Now, based on that, these two triangles are congruent. And therefore, the arc are part of the triangle. So those arcs are congruent. So you can see that using the triangle congruency, we can easily prove this is true. Okay. All right. So now we're going to look at theorem 3-3-2. It says that a diameter that is perpendicular to a chord intersect the chord and its arc. So basically what we got here now, well, before we see the bisect, there is a definition here. What means by bisecting? So the Y here is called the middle point of this arc, XYZ. then if, let me use the color, if this part is congruent to this part, so basically xy is congruent to uh, zy. And that if that's the case, then y is called middle point. So that's our definition here. And then any line go through this y, we call this line bisect the arc. So basically, before we can talk about this theorem, we have to define our terms, which is bisecting the chord and arc. Okay. And we know how to bisecting a chord. We learned that before. It's basically a middle point, and anything goes through that bisect the chord. Here we just extend that definition to arc. All right. So we got theorem 3-32. Okay, and we're going to prove that. Okay, we got a circle, we got a chord, and we have a diameter that is parallel to the chord. Okay. Well, the reason that a perpendicular, this is very important because you could have something like this, the but that's not perpendicular. So this one has to be perpendicular, diameter perpendicular to a chord that bisect both the chord and the arc. Well, again, we can use um, the triangles to do that. So we can draw the line like here and like here. Okay. And we know that the diameter of that perpendicular, so it's 90 degrees. And uh, the top triangle, this is a right triangle. So right triangle, we can use either LL, leg, or hypotenuse leg. So in this case, this side is congruent to this side because they are radius. And this is congruent by itself. Now, what we have here is a leg and the hypotenuse. Based on the hypotenuse leg theorem, then those two triangles are congruent. Now, if that's the case, then this side has to be congruent to that. This is our CPCTC. We use that a lot. Well, if that's the case, then uh, we can know that, and we know this angle is congruent to that angle, also based on CPCTC. So that means the corresponding arc has to be congruent. So by that, we can easily prove that the theorem 3-3-2. Okay, are we good on this one? Thank you, Grayson. Thank you, Mia. Okay, now we're going to do some get some examples and solutions. After that, we're going to uh, okay to go looking at another theorem. So we got three theorems. Well, today we're learning. Okay, we got two already. Pretty straightforward. All right. Example one, find the value of x and y. Well, x is this arc. Y is part of from here to here. Well, based on what we learned early on, we know that this line perpendicular to this chord based on 3-3-2. And then we know it actually is this diameter is perpendicular bisector. So therefore, x has to be 5. Now, we had to find y. Now, in order to find y, we're going to look, we need to have something to about the angle. Well, we know that this chord is 10. We also know this arc is chord is also 10. So therefore, they are congruent. Then based on 3-3-1, then the corresponding arcs has to be congruent. So that means this arc is 86 degrees. And y is half of that. That is based on this theorem, 3-3-2, because this perpendicular, this uh, diameter that perpendicular to the chord bisect both the chord and the arc. So therefore, y will be half of 86, which give us 43 degrees. So that's how we find both. Okay, are we good on this one? All right, so now we're going to looking at example 2. So example 2 here is find the length of a chord, and that is distance 5 from the center of a circle with radius 5. Now, in geometry, when we're trying to find the distance or length, you know that we are going to use Pythagorean theorem. Okay, so in this case, well, what we know is we know that from here to here is 5. And we know the radius 8. Well, now, and we are trying to find the length of the chord. Length of the chord is from here to here. And but we know that this one is half. So AP is half of AP, which means APE, AB, sorry. AB just 2 times AP. Well, from AP, you can see this is a right triangle. 8, 5, and we don't know what that x is. So then we call that, we know x squared plus 5 squared is 8 squared. And we got x squared equals 8 squared minus 5 squared. Now, there is actually a trick we can play. It's called difference of squares. Is a squared minus b squared. That is equal to a plus b times a minus b. Sometimes when we do that, we can actually calculate that in our mind. It's called mental math. So we got a plus 5, then times a minus 5. So this will be 13, and this will be 3. So therefore, we got 39. And so the x then will be square root of 39. So that's all we got. Okay. And because the theorem 3-3-2, this x is half of AP, so AB is 2 times x, give us 2 times 39. So that's how we can find this. Okay? Yeah, we good on here? All right. Uh, Now we're going to looking at the third theorem in the same circle or in congruent circles, because it has to be either same or congruent. Then then it only makes sense under this condition. We talk about equivalent congruency of chords and arcs. Okay, chords equal distance from the center are congruent. And number 2, congruent chords are equal distance from center. So these two we call at converse, basically just other way around. So we know if the chords are equal distance from the center, there has to be congruent. The other way around is when we say, so basically when we do converse, it said if A, then B, that pattern. The converse is if B, then A. So you can see that uh, the A will be equal distance, B will be congruent. So number 2 is we start with congruent chords, which is B, then prove that it's equal distance, which is A. Okay, so we can see that. You can see the graph here. Um, we're going to find the value of x. In order to find the value of x, we first of all we know that if this is a 3, then this side has to be 3. So therefore RT is 6. Well, if RT is 6 and we know UV is 6, according to this theorem, then they should have the equal distance. So that means x is equal to 4. So we find that. Okay. All right. Well, let's do some work here. First of all, if PQ, oh, we got this graph, if PQ is congruent to XY, can you congruent that the arc PQ is congruent to the arc XY and why not? Okay, think about the theorem we just went through. We got theorem, let's call them theorem 1 and theorem 2 and theorem 3. Now, theorem 1 said that corresponding uh, congruent chords, which that means that the arcs are congruent and congruent arcs. So either way, we just use this one, arcs. So that means we can go both ways. Congruent chords means we got congruent arcs. Congruent arcs means we got congruent chords. So that's our theorem 1. Now, theorem 2 is talking about a diameter that is perpendicular to the chord bisect both chord and arc. So this is called bisect arcs and chords. And theorem 3, we talk about um, uh, equal distance. So equal distance implies congruent chords. Yeah, sometimes you can write in your own words or write in a simpler way that can help you to remember the theorems. Okay, now you can send the answer on the chat. So to the first one, if you can see this is the graph. If PQ, that's the arc, congruent to arc XY, can you congruent uh, the arc PQ is congruent to arc XY? Why or why not? Okay, you just say either yes or no, then give the theorem, which theorem that is based on. Okay. Yeah, if you're not quite sure, you can always type IDK, okay?
It's not sending. Do you want me to say it out loud?
No, just into the chat, okay? Can you use
It's
the
not
chat?
sending for some reason.
It's not sending? Huh. Could you try it again? Okay. Okay. Oh, we'll wait for Mia. Okay. Mia, what's your answer? You can just in the chat. Okay, which theorem we're using? That's important. We've got three theorems. Theorem one, theorem two, theorem three. Very good. Yeah. Grayson, what's your answer?
But yes, and 331.
Okay, very good. Number two, if PQ is congruent to RS, so we're looking at different circles. Can you conclude uh PQ, arc PQ is congruent to arc PS, RS?
I want you to give me your top three songs on Bully by Ye. This track list has a lot of highs, guys. I'm not gonna lie to you, Lou. This is actually gonna be pretty difficult, but I'll give you what I have right now. All right. So,
Grayson, is that you?
sisters and brothers.
Yeah, sorry, that was one of my siblings just turned on the TV.
Okay, no problem. Okay, what doing number two? Okay, yeah. If you're not quite sure, you can always type IDK. Okay,
My chat is being weird and it's not letting me send anything.
huh? Yeah. So just wait for Mia, and once you're done, then you can say it. Okay,
I love the writing on that.
Mia. Yeah. Okay. Grayson, what do you
What?
think? Number two.
Yes, and it would be the same 331.
Well, there is one thing we don't know yet. Is we don't know if those two circles are congruent. It looks like congruent, but
Hmm.
there's no definite, we don't know yet because it didn't tell us. So because we're missing that information, then we cannot make that conclusion. So the only way that we can say yes, and also using 3-3-1 or theorem one, is when those two circles are congruent. Okay, good on
Okay.
this one?
Yep.
Okay, Mia, we good?
Hey, Alexa, turn on my lamp.
Okay.
All right, so let's do number three. Study the diagram below and tell what theorem justify each statement. A, LK is equal to 8. B, OE is 3. And C, and LK is congruent, the arc. LK is congruent to arc GH. So you just list out which theorem. So you can say theorem one, theorem two, theorem three. Okay. Okay, Grayson, what's your answer for A?
Um, LK equals 8.
Yeah,
Wait,
okay, which theorem?
338 or 1, sorry.
No, it's not one. One said congruent chords implies congruent arcs, but we don't know yet. So LK equal to A is based on the fact that LE is 4. Well, that means LE is
I'm gonna get trapped there. So yeah, for sure.
uh this is based on theorem 2. Theorem 2 is that the line here, because you can see the right angle, that bisects LK. So therefore, if LE is 4, then EK has to be 4. So therefore,
Who has the best
this is 8. So this is theorem 2.
Olivia Rodrigo just announced her
Now,
third
uh,
everything.
Grayson, what's your for B? Which theorem used for B?
333.
B said OE is 3. Sorry, this is a 3. And we already know based on this one, CK is 8, the GH is 8. So they are congruent. And based on the third one, 333, then equidistant means congruent chords. So we have that. Um,
This album is about
how about C?
again with Daniel Negro, who also worked on Sour and Guts. Olivia told British Vogue that fans can expect a lot of sad love songs.
Grayson?
She said in one song,
331 for
Yep.
3 for C.
Yep. Very good. That's it. Okay. Now we're going to do some calculation. Uh, number 4, we know AB is 16, OM is 6. We're trying to find the radius. Yeah, good job, Mia. Mia. Grayson?
10.
Very good. Good job. Number 5, we know PQ is equal to 10, and the radius is 13. What is OM? Basically, what's the distance? Yeah, good job, Mia. And Grayson?
It's 12.
Yep, very good. Okay. And this one we're going by step by step. Oh, what happened here? Oh, let me do something here. Okay. Let me finish this up. Okay. All right, that should fix it. Okay. We're going to prove the part two of theorem. So we got part two of the theorem is here. We got part two. Is that congruent chords have congruent arcs. And we got the circle here. All right. So given we got circle, we got AB is congruent to CD. AB congruent to CD. Then OY is perpendicular. OY is perpendicular to AB, and OZ is perpendicular to AC. So we're trying to prove that OY OZ. Actually, this is the third theorem. The third theorem. Theorem is part two, the 3-3-3. Congruent chords are equally distant from the center. Okay, so we're going to prove that. This 3-3-3. Okay, we can just go over that together. Well, first of all, we're going to draw a radius and OA and OC. So you can see here OA and OC. Now, this actually, the reason is based on the concept way back, is that any 2 points we can draw a line. Okay, so we have that. And then we know OY is perpendicular AB, OZ is perpendicular CD. Well, that's given. That's from here. And we know AB is congruent to CD, and that means AB equal to CD. That's also based on the given. We already have that, it's given. And we know half AB is equal to half CD. So this actually is called division property of equations. That means if you A equal to B, then we can divide by same thing on both sides. So we already have AB equal to CD. So if we divide by 2 on both sides, then that works. That's based on division property. And we also know AY is equal to half AB and CZ is half AB. Well, that's the theorem 3-32. That means this line by the perpendicular bisector. And if that's the case, then AY has to equal to CZ because AY is half AB. We know AB is congruent to CD, so AY is congruent to CZ. So that. And OA is congruent to OC. Well, that because they are the radius, same radius of the same circle. So therefore, we can show that now we got the right triangle. One is here, one is here. And we already know this is congruent to that. And the hypotenuse is congruent, also congruent. That means from the hypotenuse leg theorem, we can show that those two right triangles are congruent. So that will be the HL theorem. Then at this part, this basically is CPCTC. Congruent part of the congruent triangle congruent. Okay. Now, suppose in theorems 3-3-3, which means that the same chord, if the chord are congruent, they should have the same distance. Or the other way around. Okay, now this one says suppose in this theorem, instead of word circle or circles, and we replace them with sphere and spheres, is the resulting statement true? So we look at here, instead of same circle, we change that to sphere. And here we change that to circles, to spheres. Does this conclusion here, those conclusions are still true? Okay. So Mia, you go ahead first. Yeah, Mia, you there? Yeah. What is the answer for this one? We're looking at the last, this number 7. Suppose in theorem 3-3-3, the words circle and circles are replaced by sphere and spheres. Is the resulting statement true? So basically, we're looking at uh, here. So replace the circle with sphere and circles with spheres. Yep. Grayson, what was the answer on this one?
You're gonna draw.
Huh? So what's your answer for this problem? Number 7. Can you see it?
Wait, sorry, I'm trying to find it.
Yeah, can you see it? Number 7, suppose that in theorem 3-3-3, the words circle and circles are replaced by sphere and spheres. Is the resulting statement true?
Oh, no, I can see it, sorry. Uh, the circles are congruent.
Well, what has nothing to do with that. We're going to replace we have this statement, theorem, is in the same circle or congruent circles. So the problem 7 said, if we replace the circle with sphere and the circles with spheres, well, the result, basically these two statements, 1, 2, these two statements, are they still true? Hello, Grayson?
Hi.
Yeah. What's your answer? Yeah. Do you understand the question?
Not really.
Well, here we're talking about same circle. Like it's here, we said that the chords are equal distance from the center are congruent. Or if the two chords are congruent, then their distance to the center are the same. So equal distance. And we just go and change that. Instead on the circle or the congruent circles, we're going to look at a sphere and congruent spheres. Would that the same two statements are still true? Good. Yeah, Grayson, what's your answer?
So all the radii are equal.
Well, has nothing to do with the radii. We're talking about the chords on spheres, either on the same sphere or on congruent spheres.
Oh, congruent spheres.
No, that's not the answer they're asking. They're asking this two statement. Chords equal distance from the center are congruent, or congruent chords are equal distance from the center. So if you got a sphere instead of a circle, would that still true? So we got a sphere like this, maybe. And yeah, it's kind of hard to draw that sphere because it's 3D. But if we have a chord somewhere from here to somewhere here, and there's a center, and we have another chord from here to here, because they are on the, if they are congruent, the distance to the center is that will be, or the distance be equal distance. That means that the same distance. You understand?
So is it asking if they would be both the same distance?
That's been the two statement. If we change that instead of circle or circles, will the two statement, 1, 2, are still true? So,
Sorry, you're breaking up.
okay. And we're talking about, instead of talking about circle or circles, we're talking about sphere. So if that, will those two statements, 1 and 2, are those two statements still true for sphere or spheres?
Yes.
Yep. All right. So that's what we have basically for this lesson. And
It's so funny how one
I'll see you guys next week. Okay.
Okay, thank you.
No problem. And I'll send out the homework. Okay. Make sure
Okay.
you do that. Okay. Yeah. Bye.
Bye.